Today, becoming an engineer is not the automatic golden ticket people think it is. And I know that sounds crazy, because for years, everyone told you the same thing. Get good grades, pick engineering, survive the degree, get a stable job, make great money, and you're set for life. But most people are missing what is actually happening right now. I'm not saying engineering is dead. Engineering is still a strong field. In fact, the Bureau of Labor Statistics projects architecture and engineering occupations to grow faster than average from 2024 to 2034. But the old version of becoming an engineer, the version where you memorize formulas, get the degree, apply to hundreds of entry-level jobs, and expect companies to train you from scratch, that path is getting harder. Because companies are not just looking for people who can do engineering anymore. They are looking for something much more valuable. They want people who can take messy, real-world problems, use technology, build solutions, explain those solutions clearly, and connect them to business impact. And while thousands of students are grinding through the same classes, the same internships, the same resume templates, and the same entry-level applications, a smaller group of people are positioning themselves completely differently. They are not just becoming engineers, they are becoming technical problem solvers. And that is what I want to show you in this video. By the end, you'll know why traditional engineering path is becoming more competitive, what you should be targeting instead, and the 4 skills that can make you way more valuable than someone who only has a degree and a list of technical classes. So let's start with the hard truth. Hard truth number 1, the degree alone is not good enough anymore. There was a time when simply having engineering on your resume made you stand out. But now, thousands of students graduate with the same degree, the same projects, the same CAD assignments, the same lab reports, and the same line on a resume that says, strong problem-solving skills. And hiring managers are looking at all of that and asking one question. Can this person actually create value, not just pass exams, not just solve textbook problems, not just follow instructions? Can they walk into a company, understand a real problem, figure out what is broken, build or improve a system, and communicate why it matters? That is the gap. A traditional engineering student might say, I know thermodynamics, I know circuits, I know statics, I know CAD, I know Python. But a company is thinking, can you reduce downtime? Can you improve a process? Can you automate a workflow? Can you lower costs? Can you make a product easier to manufacture? Can you explain the trade-offs to non-technical people? Can you use AI and modern tools to move faster? That is the difference. The market does not just reward knowledge. It rewards applied knowledge. Here's where most people get stuck. They think the goal is to just become an engineer, but engineer is too broad. That is like saying, I want to go into business. Okay, doing what? Design, manufacturing, automation, software, energy, robotics, construction, product development, operations, sales engineering, technical consulting. The people who struggle the most are the ones who choose the title before they understand the value they want to provide. They say, I want to be a mechanical engineer, but they cannot explain what problems they want to solve. They say, I want to be an electrical engineer, but they have no portfolio showing how they think. They say, I want to work in tech, but they have never built anything useful to a real person. So instead of becoming a generic engineer, here is what you should become instead. A product-minded, technical builder. Some companies might call this a solutions engineer. Some might call it an automation engineer. Some might call it a product engineer. Some might call it an implementation engineer. Some might call it a technical consultant. Some might call it a technical program analyst. The title changes, but the value is the same. You are the person who understands the technical side and the business side. You can build. You can communicate. You can use modern tools. You can solve the entire problem, not just one tiny piece of it. And that is where the opportunity is. Let me give you a real example of what companies actually want now. A traditional engineer might get told, we have a machine that keeps breaking down, and they might inspect the machine, review the design, write a report, recommend a part replacement. This is useful, but a product-minded technical builder goes further. They ask, how often does it fail? How much does each failure cost? Can we track the failure pattern? Can we use sensors or existing data? Can we build a simple dashboard? Can we create a maintenance alert? Can we calculate the ROI for fixing this? Can we present the solution so leadership actually approves it? This is a totally different level of value. One person is solving an isolated technical issue. The other person is building a system that saves time, saves money, and helps the company make better decisions. This is why related hybrid roles can pay well. For example, BLS reported May 2024 median wages of $121,520 for sales engineers, $101,190 for management analysts, $101,140 for industrial engineers, and a whopping $133,080 for software developers. Not because those titles are magic, not because they sit so close in value. They connect technical work to business outcomes. So what are some 4 skills that you should build instead of all the different examples we've talked about above? I'm going to be very honest about what good enough looks like, because most people waste years trying to learn everything. You don't need to be a master of every engineering topic. You need to become dangerous in the right areas. First, you need fundamentals. I'm not telling you to ignore math, physics, design, coding, or engineering principles. Those matter, but fundamentals are not the final goal. They are the language you use to solve the problems. The real skill is systems thinking. That means you can look at a process, product, machine, workflow, or business problem and understand how the pieces connect. Most people only look at their assigned task. A systems thinker asks, what happens before this step? What happens after it? Where does the failure actually begin? What constraint is slowing everything down? What trade-off are we making? What data do we need? What would happen if we changed one part of the system? That is how engineers become valuable outside of the classroom. Because in school, problems are clean. In real life, problems are messy. There is missing data. There are budget limits. There are people involved. There are deadlines. There are trade-offs. There are old systems nobody wants to touch. So yes, learn the formulas, but more importantly, learn how to map systems. If you can explain how a system works, where it breaks, and improve it, you will immediately stand out. Skill number 2 is AI, automation, and rapid prototyping. You need to learn how to use AI and automation as leverage. This is where the biggest shift is happening. The World Economic Forum says technological skills are projected to grow faster than any other skills over the next 5 years, with AI and big data at the top of the list, followed by networks, cybersecurity, and technological literacy. That does not mean everyone needs to become an AI researcher. It means you need to know how to use modern tools to work faster. A traditional engineering student might spend days formatting a report, manually cleaning data, or rebuilding the same spreadsheet over and over. A technical builder asks, can I automate this? Can I write a script? Can I use AI to brainstorm test cases? Can I build a quick prototype? Can I simulate this? Can I create a dashboard? Can I make this repeatable? You do not need to become a senior software engineer, but you should become comfortable with basic Python, spreadsheets, AI tools, data analysis, and simple automation. For example, use Python to clean test data. Use AI to generate first draft documentation. Use a spreadsheet model to estimate savings. Use CAD or simulation tools to test design options. Use no-code tools to create a simple internal workflow. Use dashboards to track performance over time. The key is not learning tools just to say you know them. The key is using tools to remove friction. This is what companies care about. Skill number 3 is business impact and ROI thinking. This is the skill most engineering students ignore. They think, I'm technical, I don't need business. Wrong. The person who understands the money gets taken more seriously. Because companies do not approve projects just because they are technically interesting. They approve projects because they reduce cost, increase revenue, improve safety, save time, reduce risk, or create a better customer experience. So when you build a project, do not just say, I designed a system. Say, this system reduces manual inspection time by 40%. Or, this automation could save 10 hours per week. This design lowers material costs by 12%. This process improvement reduces downtime by $50,000 per year. That is a completely different conversation. Now you are not just a student asking for a job. You are showing the company how you think. And this is why management analysts and other business technical roles are growing. BLS projects management analyst employment to grow 9% from 2024 to 2034, faster than the average for all occupations. Companies need people who can analyze problems and recommend better ways to operate. If you can combine that with technical skills, you can become much harder to ignore. Skill number 4, technical communication. I know everyone says this, but most people still do not take it seriously. Here's the truth. The best technical solution does not always win. The best explained solution usually wins. If leadership does not understand your idea, it dies. If your team cannot follow your documentation, it dies. If your manager cannot explain your work to their boss, it dies. If your presentation is confusing, your work looks less valuable than it actually is. So you need to learn more about technical ideas simply. If your presentation is confusing, your work looks less valuable than it actually is. So you need to learn how to explain technical ideas simply. That means lead with the answer. Explain the problem in plain English. Show the cost of doing nothing. Use visuals. Make the trade-offs clear. End with a recommendation. Most engineering presentations are backwards. They start with the background, then methodology, then equations, then charts, then maybe a conclusion at the very end. But in the real world, people are busy. So start with the conclusion. Instead of saying, thermal performance analysis of cooling system, say, new cooling system design reduces overheating risk by 32%. Instead of manufacturing process review, say, 3 bottlenecks are causing 18 hours of weekly production delay. Instead of automation feasibility study, say, simple automation could save 520 manual hours per year. That is how you sound like someone who belongs in the room. Now let me give you an end-to-end project blueprint, because this is where most people get lost. They keep adding random projects to their resume. A bridge design project, a robot project, a coding project, a CAD project, and a class assignment. But none of it really tells a clear story. Instead, build one project that proves you can solve a real problem from start to finish. Here's an example. Pick a problem like, how can a small warehouse reduce equipment downtime? Step 1. Problem discovery. Research the industry. Find out what downtime costs. Find common causes of machine failure. Interview someone if you can. Read maintenance forums, case studies, or public reports. Map the current process. Your goal is to understand the problem before jumping into the solution. Step 2. Build the technical solution. Create a simple system that tracks machine usage, maintenance dates, and failure patterns. This does not need to be fancy. You could use a spreadsheet, Python, a simple database, or a dashboard. The goal is to show that you can collect information, organize it, and turn it into something useful. Step 3. Add automation. Create alerts when the equipment is overdue for maintenance. Build a simple script that flags high-risk machines. Create a dashboard by showing downtime by each machine, cause, and estimated cost. Now you are not just analyzing the problem. You are creating a system that helps to prevent it. Step 4. Calculate business impact. Estimate the cost of downtime. Estimate how many hours your solution could save. Estimate the ROI. Even if your numbers are based on assumptions, explain those assumptions clearly. This shows that you can think like a professional. Step 5. Create an execution-style presentation. Not a school report, a real presentation. Start with the answer. Slide 1. Predictive maintenance system could reduce downtime by 20%. Then show the problem, the cost, the root causes, the solution, the prototype, the estimated ROI, the next steps. That one project is more powerful than 5 random class assignments, because it proves you could do the right thing that companies actually want. Now here is how you use this to position yourself. Do not brand yourself as just mechanical engineering student, or electrical engineering student, or computer engineering major. That's too generic. Instead, position yourself around the problems you solve. For example, I build automation tools that help operations teams reduce manual work. I design technical systems that improve reliability and lower downtime. I combine engineering, data, and business analysis to improve real-world processes. I help teams turn technical problems into measurable business outcomes. That sounds completely different. Now you are not waiting for someone to figure out where you fit. You are telling them exactly how you create value. So if you are starting from zero, here is the order I would follow. First, pick one industry. Manufacturing, energy, construction, robotics, something like that. Do not try to be interesting in everything. Second, learn the common problems in that industry. What breaks? What costs money? What slows teams down? What creates safety issues? What do customers complain about? Third, build one project around one real problem. Not a generic project. A business-relevant project. Fourth, document everything. Create a short case study. Record a walkthrough. Show the before and after. Show the tools you used. Show the trade-offs. Show the business impact. Fifth, use that project in your applications, interviews, and networking. Because now you have something to talk about that most candidates do not. Most people say they are problem solvers. You will have proof. So here is the choice. You can follow the traditional path and become another generic engineering applicant with the same degree, the same resume, and the same projects as everyone else. Or you can become the person companies actually need. A product-minded technical builder. Someone who understands engineering fundamentals, uses AI and automation, thinks in business impact, and communicates clearly. Engineering is not dead. But the old playbook is not enough. The market is telling you what it wants. It wants builders. It wants problem solvers. It wants people who can connect technical work to real outcomes. So do not just become an engineer. Become the person who can walk into a messy problem, build the solution, and explain why it matters. This is how you stand out. This is how you future-proof yourself. And that is how you build a career that is not just based on having the right title, but on becoming the person companies cannot afford to ignore.